The National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, present CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to another program, CXC Mathematics in Focus. In today's lesson, we'll continue working with trigonometry. We'll be looking specifically at bearings. In this lesson, we will use the sine, cosine, and tangent ratios to solve problems involving bearings. To take a bearing between a ship and an island, a navigator would measure the angle on the horizontal plane of the island clockwise from the north position. In the diagram, the bearing of island mark A is 60 degrees, written as 060 degrees, but it is read 60 degrees. What is the bearing of island B? Can you work that out? The four cardinal points on the compass are north, south, east, and west. The directions northeast, northwest, southeast, and southwest are also used. And if you look at the face of a compass, it will resemble that on the screen that you're seeing here. Notice the north position. The north position is our starting point, which is 0 degrees. Opposite north would be 180 degrees, which is south. East, which is to the right of north, is 90 degrees. And going the opposite direction to east, we find that if we move from north right through to west, going in a clockwise direction, west would be 270 degrees. Some important points. The angular direction of one object from another is called the bearing. So the bearings are usually measured from north in a clockwise direction. If you stand facing north, east will be on your right and west on your left. Other important points. The bearing is written as a 3-digit whole number. Example, 5 degrees. 3 digits are used, 005 degrees. It's expressed in that way because that's a standard notation, 3 digits for the degree measure. 3 digits plus the digit after the decimal point is also accepted as a measure. And this is just part, the 0.5 is part of a degree, is half a degree. Let us look at a problem on bearings taken from CXC, June 2004. The first part. Draw a diagram to represent the information given below. Show clearly the north line in your diagram. Here's what you have to translate onto a diagram. Tongue F is 50 kilometers east of tongue G. Tongue H is on a bearing of 40 degrees from tongue F. The distance from F to H is 65 kilometers. Having drawn the diagram, you're asked to calculate to the nearest kilometer the actual distance GH. And the third part, calculate to the nearest degree the bearing of H from G. Here is the solution. Look carefully at the drawing. At G, you have the north point showing there. F is to the right of G, and the distance recorded there as 50 km. At F, you see the north line again indicated there, and you see the measure of 40 degrees. Following the line going from 40 to H will be the bearing of H from F, and FH is 65 km. Now that's the drawing you're asked to produce. The distance from F to H, note that carefully, is 65 km. The solution continues here. The second part, you're required to use the diagram to do the calculations. Second part, you're asked to find GH. To find GH, we have to determine the size of angle GFH. Angle GFH is equal to 90 degrees plus 40 degrees, which will give us 130 degrees. Now using the cosine rule, we have GH squared is equal to 50 squared plus 65 squared minus 2 times 50 times 65 times cosine 130 degrees. That will give us, when we work out, we will have the first part there giving us 6,725 plus, and note that the cosine of an obtuse angle is negative, so a negative times the negative 2 will give us a positive value. So it is 6,725 plus 4,160. So GH will be the square root of 10,885, which will give us 104 kilometers. This solution continues here. We are asked to find the bearing of H from G. Here we have to apply the sine rule, which states that A over sine A is equal to B over sine B. Substituting now, we'll have 65 over sine G is equal to 104 over sine 130 degrees. Cross multiplying, we find that sine G is equal to 65 times 0.77 divided by 104. Angle G would be the sine inverse of 0.48, because when the calculation is done, we find that sine G is equal to 0.48. So to find the angle G, we take the inverse. Using your calculator, we will get angle G is equal to 28.69 degrees. Therefore, the bearing of H from G is equal to 90 degrees minus 28.69 degrees, which will give us 0.61 degrees. And when it is written in bearings form, although it is 61 degrees, it is expressed as 0.61 degrees. Here is your problem for today. In the diagram, not drawn to scale, WXY is a straight line with y due east of W and V due north of W. Calculate 1. Angle ZXV, and 2. The bearing of V from X. Here is the problem from the last lesson. In the diagram not drawn to scale, RST is a horizontal straight line and UR represents a vertical pole. ST is equal to 15 meters, angle UST is equal to 120 degrees, and angle STU is equal to 40 degrees. Calculate 1. The angle of elevation of U from S, 2. The length of UT, and 3. The length of RU. Here is the solution to the problem just given. In the diagram not drawn to scale, RST is a horizontal straight line and UR represents a vertical pole. ST is 15 meters, angle UST is 120 degrees, and angle STU equal 40 degrees. The angle of elevation of U from S is 60 degrees. Angle RSU is equal to 180 degrees minus 120 degrees, which is equal to 60 degrees. The solution continues. Part 2. The length of UT. Angle TUS is equal to 20 degrees. By the sine rule, 15 divided by sine 20 is equal to UT divided by sine 120 degrees. Cross multiplying and making UT the subject of the formula, we will have UT is equal to 15 times 0.87 divided by 0.34. This will give us UT equal to 38.4 meters. The third part of the solution. We are asked to find the length of RU. Consider triangle RTU. Tan 40 degrees is equal to RU divided by 38.4. Cross multiplying, we will have RU is equal to 38.4 times tan 40 degrees, which will give us 38.4 times 0.84. Carry out the calculation, we find that RU is equal to 32.5 meters. This brings us to the end of today's program, CXC Mathematics in Focus.
Tonight, we will continue our discussions on statistical reports. In the last lesson, we introduced the term significant figures. Remember, significant figures are those figures which stand out or are different from the overall pattern or trend. Let us examine the following graph. It represents the number of tourists who arrived on a certain island during the period 1990 to 1994. Students, you will observe that the trend of tourist arrivals over the specified period is one of steady increase. However, you will notice too that there is a sharp decrease in the year 1993, quite a contrast to the figures in any other year. This is another example of a significant figure. When dealing with significant figures, we are looking for data that can be described in such terms as highest, lowest, most, least, greatest, smallest, higher than, lower than, different from. Let us consider another example to further illustrate trends and significant figures. The table below shows the number of students from St. Martin's School who gained passes in 3 subject areas: English language, mathematics, and Caribbean history in the period 2000 to 2004. Now that you have looked at that, consider the following questions. Describe the general trend for each subject area over the given period. Write a statement about the significant figures. Let us first examine the general trend for each subject. What can we say about passes in English language? Passes in English language increased steadily over the 5-year period. There was a sharp rise in the year 2004. Mathematics, on the other hand, showed a constant decrease in passes, with the sharpest decrease occurring in the year 2001 as against the year 2000. Passes in history remained reasonably consistent over the specified period, with the exception of the year 2003, which recorded a significant decrease, quite different from any other year. What can we say about significant figures? The highest number of passes recorded in any given year was 1,000, and that was for English language in the year 2004. English language also recorded the highest number of passes overall. Despite Caribbean history recording the lowest number of passes in any given year, that is, 295 in the year 2003, this subject recorded the second highest total number of passes for the 5-year period. What about mathematics? Compared with the other 2 subjects, mathematics recorded the highest number of passes in the year 2000, but the lowest number of passes overall. Let us consider an example of another kind of report. The table below shows the degree of participation in various outdoor games by boys and girls at Springfield Secondary School. Examine the table. And now the question. Write a report showing the main trends in participation by both boys and girls in the various games. The table shows the degree of participation by both boys and girls in 10 outdoor games at the Springfield Secondary School. The total number of boys who participated in outdoor games at Springfield Secondary School was slightly more than the girls. Boys also took part in more of the games than the girls did. There was no participation in hockey by neither boys nor girls. Girls also did not take part in rugby. Cricket recorded the highest participation by both boys and girls. There was equal participation by both sexes in this game as well as in table tennis. Golf recorded the lowest number of participants from both sexes. Only one boy and one girl played the game. An equal number of boys participated in both basketball and football. The pattern was the same for the girls, even though their numbers in these two games were significantly lower than that of the boys. Boys outnumbered the girls in 4 games, while girls outnumbered the boys in 3 games. Let us now review some guidelines in both the reading of the statistical report data and the writing of the report. Before answering the question, you should examine the overall trend in each year as well as in each category. Look to see if it shows increase, decrease, consistency, or fluctuation. Be precise in describing the trend you have identified. Say what kind of increase, decrease, or consistency you have noticed. For example, steady, minimal, gradual, significant. You are not required